Question number 8. A pair of dice is tossed. The probability of not getting the sum 8 is. Okay, students, here, firstly, we should know total number of possible outcomes, right? And for that, I have already prepared a table over here. And as we know, a dice has 6 digits, right? And if two dice are tossed, then this all pair of digits may come, and these all are possible outcomes, right? So here total number of possible outcomes will be, okay, let's count: 1 2 3 4 5 6. Similarly, vertically, 1 2 3 4 5 6. 6 6 is 36. So here total number of possible outcomes is 36. Now let's find total number of favorable outcomes. And here favorable outcomes means the pair of digits whose sum is 8, right? So here let's find the pair of digits whose sum is 8. Like here 2 plus 6 8, 3 plus 5 8, 4 plus 4 8, 5 plus 3 8, and 6 plus 2 8. In this way, here we have obtained 5 pair of digits whose sum is 8. So here total number of favorable outcomes is 5. Now according to this question, we need to find the probability of not getting the sum 8. Probability of not getting sum 8 will be total number of possible outcomes 36 minus total number of favorable outcomes 5 by total number of possible outcomes 36, and finally you obtain 36 minus 5 31 by 36. In this way we have obtained the probability of not getting the sum 8 is 31 by 36. So right option is option number B. Question number 9, and this question is given from the lesson trigonometry, and question is 2 sine 5x equal to root over 3, and here we need to find the value of this x, right? So let's solve. Sine 5x equal to root over 3, and this 2 goes to RHS over here. Now sine 5x equal to, and as we know, root over 3 by 2, it is equal to sine 60 degree. Now this sine and this sine can be cancelled out, and here remains 5x equal to 60. Now x equal to 60 by 5. Now 5 1s are 5, 5 12s are 60. In this way, here we have obtained the value of x is 12 degree. So right option is option number B, 12 degree. Question number 10. The sum of two numbers is 1215 and their HCF is 81. Then the possible pairs of such numbers are. Okay students, before solving this question, firstly we should know concept of this question, right? Suppose we have two numbers, first number be 21 and second number is 28, and their sum will be 8 in 1 9, 2 in 2 4 49. Now this 21 can be written as 7 into 3 plus, similarly this 28 also can be written as 7 into 4, and in this case also their sum remains unchanged. So here also their sum will be 49. Now from this group of number we can extract this 7, as a SCF of 21 and 28, right? And after taking SCF, here remains only 3 and 4. 3 and 4, and these 3 and 4 are co-primes numbers. And as we know, co-primes numbers are those numbers which have only one common factor, that is 1, right? And according to this question, we need to find such pair of co-prime numbers, isn't it? Now, according to this structure, we can make our equation based on question, right? And here 7 is SCF, but in question SCF has been given 81. 81 into, and this 3 is first co-prime number, but in question co-prime number hasn't been given, so let's assume first co-prime number be A plus, again 7, in place of 7 we have 81 as a SCF into, and 4 is another co-prime number, so let's assume second co-prime number B equal to, and their sum has been given here in question 1215. 1215. Now let's solve. From these two pair, we can extract 81 as a common. 81 is common, and here remains A plus B equal to 1215. Now A plus B equal to 1215, and this 81 goes to RSS over here, and this 81 can divide 1215 by 15 times. So finally we obtain A plus B equal to 15, and as we know, this A and B are co-prime numbers, right? So again, we have to split this 15 in such pairs which are co-prime numbers, right? So firstly, let's break it randomly, and we can split this 15 like way 1 and 14, 15, 2 and 13, also 15, 3 and 12, also 15, similarly 4 and 11, also 15, 5 and 10, also 15, and 6 and 9, also 15, and finally 7 and 8, also 15. Here in this way we have obtained 7 pairs of numbers, but according to this question we have to select only those pairs of numbers which are co-prime numbers, right? So let's check whether it is co-prime or not. Okay, here 1 and 14, it is co-prime number. 2 and 13, it is also co-prime numbers. 3 and 12, it is not a co-prime number. 4 and 11, it is co-prime numbers. 5 and 10, it is not a co-prime number, and 6 and 9, it is also not a co-prime numbers, and 7 and 8, it is also co-prime number. So here we have obtained 4 pairs of numbers which are co-prime numbers. So right option is option number C. Question number 11, and question is, if the area of the base of a right circular cone is 51 centimeter square and its volume is 85 centimeter cube, then the height of the cone is given as. Okay students, firstly let's try to understand concept of this question with figure. Suppose this is a right circular cone, okay, and as we know, the base of this right circular cone is circular in shape, and we have formula for finding area of circle or area of this circular part is pi r square, and it is equal to, okay, here is given area of base is 51 centimeter square, so it is equal to 51 centimeter square. Again we have formula for finding volume of cone is volume of cone is 1 by 3 into pi r square h, and volume of cone here is given 85 centimeter cube. 85 equal to 1 by 3 into, and this pi r square is equal to 51 centimeters, so it should be written over here 51 into h as it is, which we have to find here. Now 3 1s are 3, 3 17s are 51. Now here remains 85 equal to h, and this 17 comes to LHS over here. 17 ones are 17, 17 fives are 85. In this way, here we have obtained height of this right circular cone is 5 centimeter. So, right option is option number D. Question number 12. If zeros of the quadratic polynomial ax square plus bx plus c are equal, then, okay students, as we know, if zeros of quadratic polynomial are equal, then discriminant, and discriminant is denoted by d must be equal to 0, and we have formula for discriminant, that is b square minus 4ac equal to 0. Now b square equal to this minus 4ac goes to RSS and becomes plus 4ac. Now let's observe here in LHS, here is b square, and sign of b always remains positive, right? So in RHS 2, sign of a and c must have same sign to get positive value, right? It means either a and b must have minus minus sign or positive, that is plus plus sign, because in both cases we obtain finally positive sign. So right option is option number D. C and A must have same sign. Question number 13. The area of a sector of a circle of radius 21 centimeter cut off by an arc of length 22 centimeter is. Okay students, here is a circle, and as we know, an arc is a piece of a circle between 2 points. So in this circle, here is a point, say P, and another point is here, say Q. Now length between these two points P and Q is said to be an arc, whose length is given here 22 centimeter. Beside this, another thing has been given here. Suppose here is a center of this circle, say O, and radius whose length is 21 centimeters, and if we draw another radius, then a sector is formed over here, and according to this question we need to find the area of this sector, right? And if we have an arc and radius, then we have a formula for finding sector, and that formula is 1 by 2 into arc into radius. Now let's solve. 1 by 2 into arc is given here 22 centimeter and radius is 21 centimeter. 2 ones are 2, 2 11s are 22. Now finally, after multiplying these two, 11 ones are 11, 11 twos are 22 and 1 23. We obtained area of this sector is 231 centimeter square. So right option is option number C.